So our change of base formula is a formula I want you to be able to use regardless of whether your calculator is capable of doing different bases or not. Okay, some of the TI-84s can do a different base. The Nspires can do a different base where it allows you to type in whatever base you want for your logarithm. But I want you to be able to do this regardless, okay? Because here we have situations like log base 2 of 9, and a typical calculator, like a scientific calculator or the 83 or some of the 84s, all they have is that common logarithm with a base of 10, or they have the log base e, okay? Now, the reason why these were derived, this was derived, is because before the days of calculators being really common, we had to use tables, okay? And they would come up with tables for log base 10, and they would plug in different, log base 10 of 0.1, 0.2, 0.3, 0.4, and they'd have these huge tables that you'd have to use to look up the value rather than just punching it into your calculator. They did the same thing with sine, cosine, tangent. They'd have tables, and you really had to know what you were doing in order to find the right value. So that's why they brought it down to just log base 10 and log base e, because they didn't want to have to make a table for every possible base. Okay? So we could use the change of base formula. Now what this formula says, though, is that we can change the base from b to whatever we want. That's what the c is. It's whatever you want. You put what you're taking the log of originally with the new base in your numerator, and then you take the log of the original base with the new base in your denominator. Okay? So the original base goes in the denominator. Okay? Or the base goes in the basement. If you guys even are familiar with what a basement is, because here in Florida you don't have a whole lot of basements. But I found that out last year. Up in Ohio, everyone has a basement, pretty much. So here we have log base 2 of 9. So we could evaluate this with a calculator by changing this to, say, a log base 10. Okay? Log base 10, the common log. Here we go. Of 9 over the log base 10 of 2. And that your calculator can do. You punch it in and you can get your result. Now, the cool thing about this is it doesn't matter what you plug in for your base. We could have also written this as the natural log of 9 over the natural log of 2. Okay? So, you can change the base by putting, by writing the ratio like you have it here. Okay? Here's another case. We could write this as the log of 16 over the log of 8. Punch it into our calculator and get a result. Or,
log of 2.
yeah, here's where it can be really useful and allow you to do things that are in your head rather than having to depend on a calculator. If you recognize that 8 and 16 are both multiple, or not multiples, but powers of 2, you could rewrite it with a base of 2. And you say, oh, well, look at what we're really doing here. It's the log base 2 of 2 to the 4th power over the log base 2 of 2 to the 3rd power. And you guys know the log with a base of 2 will undo an exponential with a base of 2, so we end up with 4 over 3. And we just evaluated the log base 8 of 16 without even using a calculator. Okay? Now, if you did use a calculator, you'd still get 4/3. But it's just two different ways of being able to do it. Alright, any questions so far? Alright, so let's see how this can be used in a problem, okay? Here we have a school district. It's growing at a rate of 3% annually. All right, so this is not an interest problem, but we can kind of think of it in the same way. All right, right now there are 10,000 students, and the current facilities can accommodate up to 15,000 students. When will we run out of room? All right, if you are ever a city planner or a city engineer or even a politician or something like that, this is the kind of stuff that you might have to consider. Or if you're a school administrator, when are we going to run out of room if we keep growing like this? Even a business would have to consider this. We're producing 10,000 units every day. Our max for our facility can produce 15,000 units a day. So if our business keeps growing, when are we gonna not be able to produce enough? All right. So you can apply this same concept to any situation, but let's get our formula here. The amount at time t is gonna be
10 times.
Okay. And notice what Luis is doing. He just said 10 instead of 10,000. No, it's okay. If you make it 10 instead of 10,000,
So the thing equal to 15.
your numbers are smaller. You just interpret your answer differently, right?
Yeah.
Your answer is going to be in thousands, and that's fine. So let's do it. 10, and then it's going to be 1 plus
0.03.
0.03. And notice it would normally be over the number of times you compound a year,
It's just compounded
but it's
annually.
annually. So it's just 0.03 to the
T power.
t power. That's what we're going to solve for. Okay? And what it's going to equal, the value of t we're looking for, is when this thing will equal, good, 15. We have 15,000. All right? So the first thing that we're going to do, good, we're going to divide by the 10. So 15 divided by 10, yeah, 1.5, and that's going to equal 1.03 to the t power. And here's where the logarithm comes in, and we're going to have to use our change of base. Okay? So we have, what log are we going to use?
Base 1 over 1.03.
Yeah, log base 1.03 of 1.03t, and that's going to give us t. But we have to be fair to both sides. So the log base 1.03 of 1.5, and here's where you can use your change of base formula. Okay? So we could use the common log of 1.5 over the common log of 1.03. I know some people will solve this a little bit different, and in essence they're kind of deriving the change of base formula over again, and that's okay. It's just preference, but yes.
Can't you just say that instead of taking the log of 1.03 of both sides, can't you just say log base 1.03 of 1.5 equals t? Oh, well, I guess.
Well, you're doing it whether you write it down or not. Yeah.
I just meant like flip the exponential into a log.
Yeah, you're doing the same thing in your head whether you write it down or not. What do we get for an answer though here? 13.717. Okay, so at this rate, guys, we're going to run out of room in 13 more years. So if a building project is going to take like 6 or 7 years to plan, get approved, and complete, we should get on that pretty soon, right? All right.